Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and strong. Now we are going to continue our chapter, and I have left you with this portion in our previous session that if you're having two parallel lines and you're having same base and different triangles between the same parallels, then what will be the relationship between the areas of these triangles? Okay, we have talked about the triangle and the parallelogram. Now we are going to talk about the relation between the area of a triangle and the another triangle made with the same base and between the same parallels. Okay, now triangles on the same base and between the same parallels, you can here see it that you're having these two parallels, AP and this BC is base. BC is the common base. BC is the common base, and you're having P and A here. So this is one triangle, okay, which you will be having that ACB is one triangle and BPC is another triangle. Now the area of these two triangles are actually the same. Okay, so can I write here area, this triangle is PBC will be equals to area of this another triangle which is ABC. Okay, as far as this case is concerned. Okay, now if you talk about this, you're having this line and the parallel is BC. BC is parallel to AR. Okay. Now, you're having point A, P, D and R. Okay. So, in that case, this triangle will be having some area and that will be equals to area of this triangle PBC. Okay. If now you'll be making one another triangle here like this, then this area will also be equal to the area of this triangle or area of this triangle. Is it clear? Okay. And if you also have this triangle here also, then be having this area which will be equals to the area of other triangles made here, with the same base only, with the same base or the equal base. What I mean by the equal base, let's see. That means if I'm having two parallels, okay, these are two parallel lines. I'm having a point A here, B here, C here, D here. Now, students, AB is equals to CD. And we are having a point here and a point here. Now, this E and F. So, here I am having one triangle and here I am having another triangle. Now, these two triangles are between the same parallels, okay. But do they have the same base, the common base? No, they are not having it. But the base are AB and CD that are equal to each other. That means they are having same base or they are having equal base. So, if they are having equal base, that means they are having again the same area. So, here in this case also area of ABE will be equals to area of CDF. Is it clear to you now? Okay. Now, the first theorem, two triangles on the same base or equal bases and between the same parallels are equal in area. Okay. So, two triangles will be having the same base or equal bases. So, we have taken the equal bases. Here, AB and this is DC. This is a parallelogram, so these two bases are equal. So, AB is equals to DC and we are having these two triangles. This is the first triangle and this is the second triangle. These two triangles are between the same base and the say between the same parallels and the base is equal, not same but equal. Okay. Right. So, two triangles of the same base or equal base between the same parallels are equal in area. Okay. And one another condition, you can take it like this, that you are having this AB and CD. So, here you are having A, B, C and D. Now, what's happening? That you are having the CD as your common base, and you will be having a triangle here. Okay, and you will be having a triangle here. Okay, all right. In the both cases, I will draw perpendicular AC. Okay, in this case AN, so sorry, it is N here. So here it is also AN, here it is also AN. Okay, and this is D and this is C. So we just alter it a little bit. Should we use a different ink here? So this is A, this is B, here it is C, and here it is D. Okay, so we are having a triangle here and a triangle here. Now these two triangles are between the same base and the same parallels. Okay, so in the same case, in this case also we'll be drawing a perpendicular here and we'll end it with this point N. Okay, now what is next? The proof. Okay, you have to prove that area triangle ADC is equals to area triangle ABC. Okay, now for this case you have to prove that area triangle ADC is equals to area triangle CBD. Understood? Now, proof. In figure, we are having area triangle ADC is equals to, because by the construction we have drawn AN perpendicular to DC, this is in the construction, you have to write it. Okay, so ADC will be equals to half multiply by base multiply by the height, and here half is half, and the base is DC, and the height is simply AN. This is the first thing. Now the second thing, area triangle ABC. If we talk about area triangle ABC, that is going to be again half base into height. Okay, that is going to be equals to half multiply by base multiply by base is here AB multiply by the height. Now height for this will be again, because the distance between these two parallel will be always constant, which is the perpendicular of it. Okay, the perpendicular on DC, and that will be again the same here. That is going to be again DC. Now AB is equals to DC. AB is equals to DC. Why? Opposite sides of parallelogram. Okay, Now, this is something AB equals to DC, so you can just put it here. Area triangle ABC is equals to half multiplied by AB. Now, what is AB? AB is, here you will be having AN, the perpendicular is AN, not DC. So, here you will be having AN, okay. AB is the base here and the perpendicular is AN. So, here it will be also the same, AN, okay. You can have a point N here also. In that case, you can write it AM, okay, and AM is equals to AN, okay, because they are both perpendiculars. So, you can write AB is equals to DC here and AM equals to AN here. That is equation number 2. Now, compare first and second, half DC AN, half DC AN. That means these two areas are equal to each other. So, okay, here we can say that by comparing first and second, we can simply say that area ADC will be equals to area triangle ABC. Understood this thing? Okay. And now we were talking about this second thing, okay, that I have told you about this. You can just prove it by this, that area here, this is A, B, C and D. Now, in this case, the area of this will be what? Half multiplied by base multiplied by height, okay. So, that is going to be M here and that is going to be N here. These are the perpendiculars. This is C and this is N. So, this area will be half multiplied by the base is DC and the height will be the DM, okay. This is for this area will be equals to half multiplied by the base is again DC and the height is actually here BN, but BN will be equals to again DM, okay. So, you can again say it DM. So, you can just easily prove these two things also in case of same base too. Same base, equal base, both are clear, okay. Now, in this figure, is any point on median AD of a triangle ABC show that the area of ABE is equals to area of ACE, okay. Area of ABE is equals to area of ACE. These two triangles we are concerned about. Now, talking about the median, because it's depending on the median word here. If I am taking a median, it is very clear to us guys that if it's median here, okay, like if this triangle is ABC and I am having a median here, a median, that means, let's suppose it's D, that means these two portions are same. In that case, the area of this triangle and this triangle will be equal to each other. So, understood this thing, this concept? Okay. Again, we are here having this triangle and this triangle. We need to prove them. So, talking about the proof here, in triangle ABC, AD is median. This implies that area ABD is equals to area ACD. Okay? And that is going to be because of, why it's going to be equal? Because median divides triangle into equal areas. Now this is the first thing we got. In triangle, we are taking this triangle, okay, BEC. Again, this portion is median, no? For this is also median because we are having these two sides, but this side is same and the midpoint of this is same. So midpoint meeting the vertices of opposite will be the median of it. So is it again a median or not? Median? Okay, so we'll be taking it as a median. Now, in triangle BEC, ED is median. So with the same reason, I can say that triangle EBD will be equals to area of it, okay. Area of EBD, this triangle will be equals to area of EDC. Now these two areas are also equal, okay. This is your equation second. Now we are going to talk about this portion. And how can you have this portion? You can minus this portion from this complete portion in order to get this portion. Okay, and this is something we have to talk about. So, by equation 1 minus equation 2, if you do that, you will be finding that this is the ABD. So, area ABD minus this area EBD. That will be equals to area ACD minus of area EDC. Now look carefully what the areas are here. Okay. Now we are going to find out the area ABD, which is this area, and we subtracted the area BEBD from that. This area we subtracted. So we are remaining with this ABE, okay. Area ABE here. Now look for this one. Here we are having this area ACD. Now area ACD is this area. And we are subtracting area EDC, this area from that. So we have left with this area only. Now what this area is? This area is this ACE. Look, ACE. So the area is here, ACE. And this is something we had to prove. So done? Okay. For the next one, in a triangle ABC, E is the midpoint of median AD. Now the figure is not given to us, guys, so we are just going to draw it. So in a triangle ABC, first we are going to make a triangle ABC. Here, and E is the midpoint of median AD. So we are having a median AD, median from A. So it's going to divide this in two equal areas, and that will be E. And BC will be divided in two equal halves, that will be BD and DC. Okay, now show that BDE. This is BDE, where the E is the midpoint of median AD. So median AD is going to have a midpoint here. Okay, that is named as E, and we are going to have this here. Now we have to prove that BED. What we have to prove? We have to prove that area BED is equals to 1/4 of area ABC. ABC is the complete triangle, and the area BED is this. triangle. Okay, so now we are going to take the same concept here, that we are having, if we are having any median, this median is going to divide this triangle into two equal areas. Okay, got it? Okay, now proof. We don't need any construction here. First, we are going to talk about this triangle ABC. In triangle ABC, AD is median. If AD is median, this implies that area ABD is equals to area ADC. If these two areas are equal, that means in relation to the area of ABC, what is it? Equals to half area ABC. This is half ABC and this is half ABC. That makes it complete the area ABC. Okay. Now this is first. Again, E is midpoint of AD. E is midpoint of AD. This implies that if this is a midpoint and it's joining the vertices, that means this is BE. BE is the median of this ABD triangle. Okay. BE is median of triangle ABD. Okay. Now, if that's so, that means area ABE is equals to area BED. Now, area ABD is equals to half area ABC here. Okay. And if these two areas are equal, that means these are half of what? Half of the complete area, which is ABD. Now, half area ABD is equals to half area ABD is ABD. It is ABD. Now, you can say that half area only area ABD is equals to half area ABC. To put the value here, half multiplied by half area ABC. Okay, and this is equals to what? ABE and BED. Now we are talking about the area BED in the proof. So this implies that area BED is equals to 1/4 of area ABC. 1/4 of it. So this is going to be your proof. Okay. Now the next question show that the diagonals of a parallelogram divided into 4 triangles of equal area. Now we are going to do this question in our next lecture, but for your I guess like you are going to do this question, so I'm just going to brief it, that what it's saying, that the diagonals of a parallelogram, that means we are going to have a parallelogram first. Okay, and you are having its diagonals. So if this is ABCD, surely you will be having AC and BD as the diagonals. Okay, divided into 4 triangles of equal area. Now you have to prove this, that this area is equals to this area, is equals to this area, and is equals to this area. Okay, so we are going to prove this in the next lecture. For today's session, it is now okay. Okay, so take good care of yourself and bye-bye.